Before we start anything, let's think about how we can solve this problem. In this question, there are two parts. The first one is x cube and the second one is square root 1 plus x squared. So, we can consider integration by parts method. Actually, we know the integration of the x cube term, which is x to the power of 4 over 4. But after that, we would have to integrate x to the power of 4 over 4 with differentiation of the square root 1 plus x squared when we use integration by parts method, which is very complex. So we can give priority to square root value of 1 plus x squared. Since there are no direct integral for that, so what we can do? We have our most integration equation, integral fx to the power of n into f dash x equal to fx to the power of n plus 1 over n plus 1. Using this equation, we can integrate square root 1 plus x squared. Let's jump into the question. 15 is a constant value, so we can bring this 15 value outside of the integral. Square root value of 1 plus x squared equal to 1 plus x squared to the power of half. Now we have fx equal to 1 plus x squared. We have n equal to half. So we need to find differentiation of the fx. Differentiation of the fx means differentiation of the 1 plus x squared. Differentiation of the 1 equal to 0. Differentiation of the x squared equal to 2x. So we need to find this 2x value. How we can find this 2x value? From x cube we can find one x term. After that we can put 2 in the numerator. To cancel out this numerator value 2, we can put another 2 in the denominator. Denominator value 2 is a constant, so we can bring this 2 value outside of the integral. Now we have fx to the power of n and f dash x. So using this equation, we can write 1 plus x squared n plus 1 value. N plus 1 value equal to half plus 1. Half plus 1 equal to 3 over 2. So we can write 1 plus x squared to the power of 3 over 2 over 3 over 2. We can write x squared term as it is. Now minus integral 1 plus x squared to the power of 3 over 2 over 3 over 2 into differentiation of the x squared. Differentiation of the x squared equal to 2x. Denominator value 3 over 2 is a constant. So we can write this 3 over 2 value outside of the integral. After that we have 2 over 3 integral 1 plus x squared to the power of 3 over 2 into 2x. Now we can get 2 over 3 as a common factor. Then we need to find integral 1 plus x squared to the power of 3 over 2 into 2x value. 1 plus x squared just like fx. 3 over 2 value just like n. 1 plus x squared differentiation or 2x value just like f dash x. So we can use the equation fx to the power of n into f dash x integral equal fx to the power of n plus 1 over n plus 1. Then we can write 1 plus x squared to the power of 3 over 2 plus 1 equal to 5 over 2. So we have 1 plus x squared to the power of 5 over 2 divided by 5 over 2. Denominator value 5 over 2 is a constant. So we can write outside of the bracket this 5 over 2 value. Then we have 2 over 5. After that we can multiply all the terms from phi value. Finally, we need to substitute upper limit and lower limit for these answers. First one, 1 plus x squared to the power of 3 over 2 into x squared. Upper limit 1 minus lower limit 0. Second part, 1 plus x squared to the power of 5 over 2. Upper limit 1 minus lower limit 0. 1 plus 1 squared equal to 2. Then we have 2 to the power of 3 over 2 into 1 squared 1 minus 1 plus 0 1. 1 to the power of 3 over 2. 0 squared 0. 1 plus 1 squared again 2. 2 to the power of 5 over 2. 1 plus 0 equal to 1. 1 to the power of 5 over 2. 2 to the power of 3 over 2 means 2 to the power of 2 over 2 into 2 to the power of half. Then we can write 2 to the power of 1 into 2 to the power of half. 2 to the power of 1 equal to 2. 2 to the power of half equal to root 2. Then we have 2 root 2. 2 to the power of 5 over 2 equal to 2 to the power of 4 over 2 into 2 to the power of half. 2 to the power of 4 over 2 equal to 2 to the power of 2. 2 to the power of half equal to root 2 value. Then we have 4 root 2. Now we have 5 within bracket 2 root 2 minus 0 minus 2 within bracket 4 root 2 minus 1. Then we can remove the brackets and get the final result 2 root 2 plus 2.